Okay. So we're moving on now to 2F, derivatives of exponentials. And I'll just point out on the very back page of your notes book, remember we've got that sort of formula sheet. This is what you're allowed to take into the test with you. We'll provide a copy of it with you, so this is what you'll get. And if you look down, all right, it's just got all of the rules that we're going through. So we've done simple diff, we've done chain rule, we've done product rule, we've done quotient rule. And so this is a good summary sheet, good one to have open as you're going through the exercises and doing your revision. We're at exponentials now, and what you'll find is we're going to differentiate exponentials, but it's going to compound because we're going to be using the product rule in order to differentiate exponentials. We're going to be using the quotient rule in order to differentiate these. So this is our rule for exponential functions, okay? If we have e to the power of x, then the derivative is e to the power of x, okay? The function and the derivative are the same. This is the only function in all of maths for which the original function and the derivative function are the same, okay? However, if we have e to the f of x, e to the power of some function, then the derivative will be f dash of x, e to the f of x. So let's get straight into the examples then. Here I have 3e to the power of 2x plus 5. So it's of this form, right? E to the power of some function, where the function is 2x plus 5. So my derivative, we're going to do this one in one step. The 3 just hangs out, right? The 3 is just staying there. It's multiplying whatever the derivative is, just like with simple differentiation. The 3 stays there. So then I'm looking at this, e to the f of x. Okay, first part is f dash of x. So derivative of 2x plus 5, 2. All right, and then it's just, all right, got f dash of x, then it's just e to the f of x. So we'll put here e to the 2x plus 5. Okay, that's our answer. You can simplify it to be 6 e to the 2x plus 5 if you want to. All right, looking at B, we have x squared times e to the x. X squared times e to the x. Oh, they're a product. We're multiplying them. Okay, how do we differentiate a product? We use the product rule. So we identify u, use the first multiple. We identify v, the second multiple. Okay, u dash will be 2x. v dash will be e to the x. And then we just smash them together according to the product rule. If you can't remember, look at the back. U dash v times uv dash will be u dash v plus uv dash. All right, now I hope I didn't skip over v there. I probably did that a little bit quickly. If if the function is e to the x, the derivative is e to the x. So v and v dash are going to be the same. That's how I differentiated that part. Okay, let's go through C then. And C, we have f of x is equal to, we have 3x to the 4, take e to the square root of x. All right, that's what's happening at the top. And all of that is on top of the square root of x take 3e to the x. Okay, we have here one function divided by another function. Quotient rule, we have u divided by v. So we identify u, we identify v, all right, so all I've done so far, I've described that's the top function, that's the bottom function. Now we're ready to differentiate, okay? U dash, all right, so just differentiating here term by term. 3x to the 4 goes to 12x to the 3. All right, it's much easier to write that rather than having the number 3 times 4x to the 3. Either's fine, okay, that's the first part. But then here, here we're doing our derivatives of exponentials again. I have e to the power of x to the half. So it's e to the f of x, all right? Where f of x is x to the half. All right, what's the derivative of x to the half? Half x to the minus half, okay? E to the f of x, f dash of x, e to the f of x. All right, I can write that a bit bigger. Okay, so we're happy with that part, I think. Here we've got e to the x to the power of a half, okay, e to the f of x. So the derivative goes out the front. Derivative of x to the half is half x to the minus half. That's what that part is. And we're multiplying that by e to the f of x. All right, any questions about that? Okay, so then for v dash, okay, here we have a function to the power of n. So here you can see all of our rules compounded. All right, a function to the power of n, I have to use the chain rule. All right, a function to the power of n, we go n f of x to the n take 1 multiplied by the derivative of the inside, 1 take 3 e to the x. The derivative of x is 1, the derivative of e to the x is just e to the x. The 3 just hangs out. Okay, so you can see in this question, we've gone, all right, got to use the quotient rule, got derivatives of exponentials, and I've got the chain rule. All of those rules combining in this one question. This is a sort of a 3-mark question because of the amount of differentiation involved. All right, and then all you have to do, smash it together. Okay, you've got your u dash, v dash, let's bring it all together. We're told f of x, so f dash of x will be u dash v, 12x to the 3, take half x to the minus half e to the x to the half. All right, u dash, I'm putting it in brackets because it's all of u dash multiplied by all of v. Okay, u dash v, take away u v dash. Put u in brackets, put all of v dash in brackets. U dash v, take away u v dash. All right, and so this step here, it looks like it's an enormous complicated mess, and it is, but all you're doing is copying it from here, okay? U dash v, take away u v dash, all on top of v squared.
Shouldn't v have the power of 1/2?
Yeah. That one, good.
V. Wait.
Right,
Yeah.
here,
Yeah.
this one.
Yeah.
And that's u, yeah, good one, yep, good pickup. All on top of that squared, and so because we're squaring the square root, it will just get rid of it. You can write it with it, squared, or you can just leave it out. Okay, so there's a 3-mark question there. So let's just talk about that one again quickly. We identified we need to use the quotient rule. That's our first step. We've got one function divided by another. So we set it out. We've got u, that's the top, v, that's the bottom. Okay, that's easy. Then we've got to differentiate the top. Okay, so here we had e to the x to the power of a half. E to the f of x goes to f dash of x, e to the f of x. For v, we had a function to the power of n, so we had to use the chain rule, n, f of x, n take 1, multiplied by the derivative. And once you're there, that's all the work done. You just bring it all together. Make sure you copy it properly. All right, so that's derivatives of exponentials. It'll start easy and it'll get progressively hard. So let's maybe spend some time going through that one.